Hello students, today we will learn how to convert JK flip-flop to T flip-flop. The first step is to derive the truth table of the destination and the excitation table of the source. Here our source is JK and our destination is T. So we will require the excitation table of the source, that is excitation table of JK, and the truth table of the destination, that is truth table for T. Let us start with the truth table. Truth table of T flip-flop. And here the excitation table of JK flip-flop. Truth table of T. T, Qn plus 1. So 1 is 0 and is 1. Don't care. So we know Qn value doesn't matter, but if T is 0, Qn plus 1, the Qn will be put here, because when T is 0, Qn is not changed. Qn plus 1 will be same as Qn. If it's 0, then it will be 0. If it's 1, this will be 1. But when T is 1, Qn plus 1, in Qn plus 1, the complement of Qn is put. That is, when T is 1, Qn is toggled, Qn bar is put in the Qn plus 1, means when T is 1 and if Qn is 0, then it will be toggled, that is 0 will be 1. If Qn has 1, then in the column Qn plus 1, if it's 1, it will be 0, in this way. Excitation table. After so many videos, we all must remember the excitation table of JK. That is the 4 combination as they are 0 0 0 1 1 0 1 1, and the J column becomes, we just don't need to remember everything, just the J column we should remember, that is 0 1 x x, and the inverted sequence is put in the K column x x 1 0. It's done. Now it's time to make the conversion table with the help of these two tables. Conversion table. Okay. How many columns will be there? We will first start with truth table. That is T, Qn plus 1, Qn plus 1 is common, J and K. So T, Qn plus 1, J and K. T, Qn plus 1, J and K. It is like this. So when T is 0, Qn is 0. When T is 0, Qn may be 1. When T is 1, Q is 0. When T is 1, Qn 1. Qn is also 1. So these are the 4 possible combinations with T and Qn. Now using the truth table of T, we will find the value of Qn plus 1. That is, when T is 0, Qn plus 1 will be same as the Qn. From the truth table we can finalize it. That is, you can conclude it. So Qn is 0, Qn plus 1 is 0, Qn is 1, Qn plus 1 is 1. But when T is 1, Qn plus 1 has the complement of Qn. That is, if it is 0, Qn plus 1 become 1. If it's 1, it is toggled, becomes 0. Now Qn plus 1, J and K, these 4 columns. Using the excitation table of JK flip-flop, we will have the values of J and K. 0 0, when it's 0 0, 0 0, it's 0 and x. When it's 1 1, it's x 0. 0 1, 1x, 0 1 1x, and when 1 0, it's x 1. Now from this we have to derive the K map of the last 2 columns, that is J and K. So K map of J, T and Qn means 4 cells. T, Qn 0 1 0 1. Now for J, 1 don't care. For T0 and Qn1, T0 and Qn1, 1 don't care. 1 1 0 1 0 1, and another don't care. 1 1 1 1, another don't care. So you'll pair like this, including the 1, and J becomes, in these two numbers the common is T1, that is T. If this 0 was common, then it will be T bar, but here this one is common, that is J equals to T. Next we have to draw the K map of K. T and Qn 0 1 0 1. So here K has a don't care for T0 Qn 0, so T0 Qn 0 we have a don't care. For 1 0 a don't care, 1 0 a don't care, and then 1 1 we have 1, so we'll pair it like this, including the 1. So K equals to, here another, again the here in between these two numbers T1 is common, that is it will also be T. Now we will draw the logic diagram. We'll first draw a block. The source will be put here. Our source is JK because we are converting JK to T. So J and K, Qn plus bar. A clock will always be there. It's CLK. Cool. And J is T, K is T. So J is T, K is also T. Thus our JK to T flip-flop conversion is done. Thank you.